Greetings and welcome back to the lab. This time we're going to do some hacking. It turns out that the project that I just built, it occurred to me that there's something I could do. In the notes it did say that the power supply could be between 3 and 12 volts. Now, the thing I'm concerned about with the 3 to 12 volts is the chip. I don't want to overload the chip. But I did look up the spec sheet on the chip, and it turns out it can go up to 16 volts. I'm not going to go quite that high, but I also was looking at the previous one, and this chip here can also go up fairly high. What I'm thinking about here is this battery pack, which theoretically would be a 4.5 volt battery pack, except that I've put rechargeable batteries in. And if you didn't know, like alkaline batteries are 1.5 volts, but rechargeable batteries are generally 1.2 volts. So the three of these here only totals out to 3.6 volts. And digital chips, at least years ago, used to consider a high signal to be close to 5 volts. Well, this is not nearly 5 volts. And I'm kind of wondering if some of the problems I'm having between these two projects is because we're not close to 5 volts. And I'm wondering also, on this one, the volume was really, really low. Now, there's no amplifier built into this, so it's relying on just the output from this chip to generate the tone. And I think if the voltage was higher, then the speaker would probably be louder. Also on this one, there is an amplifier for the microphone, but maybe if the voltage was higher, then we'd get more amplification, and this would be more sensitive. So with that thought in mind, I happen to have these little boards that have a micro USB connector on them, and it's what I call a breakout board. And you can find these usually to come in like packs of 5. I think I bought 10 total. I've used them in other projects, but the beauty of these is all I need is let's see if I can get that up close. So we've got, wow, I need my old man glasses. I was going to try and point out where ground and 5 volts are. So because it's a breakout board and because it's USB, there are data lines here, but we're not going to use those. We're going to use this for power. And so this is ground here, and on the opposite side we've got 5 volts. I have a couple of these set to go, and I have some wire. So what I'm thinking is, let's push this one out of the way, and let's set this one up since I'm already disconnected, and it looks like, no, I got to clear one of those holes. For connecting the power. So let me get my solder sucker, prime it, and heat up the solder. Oop, that cleared on its own. Okay, so now I also have these wires. Now you can buy these on eBay or Amazon. They usually come in like a pack of 40 in various different lengths, and either with the pin or the socket. The pin would be considered male and the socket would be considered female. But I just happen to have a couple of them right here. I could very simply just stick these, let's see if this will actually go into the hole or if I need to strip the wires. And I think I'll use the lighter color as positive and the darker color as negative. So, yep, it went in. And let me do something real quick. There we go. And they're generally called DuPont connectors or DuPont style connectors. I think I got the style connectors, not the actual ones from DuPont. And yeah, it's going to be a little tricky trying to push that through. Oh, I see what happened. It didn't go through. I'm going to need some assistance from a pair of pliers. Oops, sorry about the bounce there. But you get the idea. I'm just trying to, if I can stick these pins through, this will be that much neater. Otherwise I'm going to have to strip the wires. Yeah, I think I'm going to have to strip the wires. Alright, not the end of the world. So I can cut off, get my wire cutters, that'll be more efficient. Cut off the ends. You can use wire strippers, or sometimes the stuff is brittle enough you can do it with a fingernail. Okay, let's see. Let's try that again. See if I can get them lined up. I should probably tin the leads before I do this, but we're going to go for broke. Yep, I had to tin the leads. So tinning the leads basically means adding a little bit of solder. It does make it so that twisted wire, like the stranded wire, when you twist it together, only holds together just so well. And sometimes these cheaply made ones, while they're electrically conductive and will work once you get them together, the wire really doesn't act like copper. So I think it's probably like, oops, what am I doing? Copper alloy of some sort. So I'm just going to, now you probably don't want to put this right on the table like I'm doing. And clean off my soldering iron after that. Okay, let's try that again. So I want the green to be positive, only because it's a lighter color. And because these two wires are kind of bonded together. So it just makes it, there we go. We're in. So, we're almost there, folks. If I'm right, I probably should have queued up some music so we could actually demonstrate this device again. But, so now what I can do is I can take these, I know the pins will go through here. So the green is the positive. Yep. And the blue, which is darker, is the ground. Okay, this is going to be a little janky. Let me get my helping hands to help me out here, because it wants to twist on me and it's already falling out. Yep, it's completely fallen out. Alright. Really? How many times do I have to tighten up the same connection? Alright. Oh, yeah, it's already on there. So, yeah. Let's get the ground first. Oops, I got some solder in the next hole over, but that's not a problem because we're not using data. The one thing though is you want to make sure these two wires don't touch each other when you wire it up. Because you're going to hook up some kind of USB device, and now you're going to put, if they short out, you're going to put a lot of demand on that device. When you first test this out, make sure everything's good. You probably don't want to hook it up to your computer or something like that. I have a power bank. Here it is. And let's find ourselves a, oops, I thought that was connected. Alright, well, I have a cable. I can now hook up and get rid of the helping hands. I can hook up this cable, Got to get it right side up. There we go. That's in. Now we'll plug into the power bank, and that should be operating, but it's not. So I'm going to unplug it quickly because something has gone wrong here. Either I've got it backwards, I got positive, I got negative. I'm connected there. I got positive and negative there. Maybe I'm not plugged in all the way. I know I'm not in the wrong direction. Yeah, that's plugged in all the way. Could be my power bank is dead. Let's check the battery. Yeah, power bank is dead. Alright. Fortunately, I have a backup. This one's also a flashlight. Now I know the flashlight works. Get that right side up. Oh, wow, that is bright. Those are probably pretty dazzling on camera. Let's see if I can't bring up some music. Gotta grab the right mouse on my desk here. Okay, no attribution. Let's try Boardwalk by Track Tribe. Moving a little. Oh, it's when I was talking it's moving. Is that right? It is more sensitive for sure. Let me turn the music up a little bit. Okay, that's a reasonable demonstration, and it's actually now reacting to my voice on some things. Interesting. Alright, well, it is definitely more sensitive at 5 volts, so this is a win. Now I'm going to unplug that, and let's do the same thing. Let me move this out of the way. And good. Alright. We know we're disconnected on that. We need a couple more wires. So let's see, we can go with yellow and green or yellow and orange. I think I'm going to go with the yellow and green here, just because they're the next 2 wires. And you see they just come disconnected like that. Now for this one, I can wire onto the adapter here and still wire in the way they were intending here. Let's see. Yeah, I need that screwdriver. And a smaller screwdriver. Good old-fashioned Radio Shack screwdriver set that I found recently. Jeweler screwdrivers, I think is what they called them. Let's just disconnect this one. Okay. Let me get rid of the battery pack. Now I have an extra battery pack lying around that I can hook up into some project. What I could do theoretically is take this whole thing off and hardwire to the board, but I'm not going to do that just yet. That could be a second step. This one should go a little bit faster because I should be able to hook these wires in. And what did we figure? The positive was at the chip, on the side of the chip. So I'm going to again put the lighter color as positive and the darker color is negative. This way you don't always have to have red and black. But there's always that confusion because you never know, whoever's manufacturing something, why they chose particular colors. Here I'm telling you, oops, it's like there's something wrong with this header, that it just isn't working right for me. I just did all of that and it came right back out again. So let me loosen up the screws. Alright, I think that's secure. Yeah, that feels better now. And again, it's the same thing. I'm going to, lighter color goes to positive, darker color goes to negative, or ground. Gotta line them up. See if I can do this without the helping hands. No, it's not going to work. The problem is the whole thing wants to move, and things are sticking to the speaker. That must have a better magnet than usual. Let's get the cable as everything else falls. Alright, now when I built this thing it was not very loud. Let's hope this is a little better. What just happened? It just stopped. Did the battery just die on this thing too? No. Something's disconnected or something burned out. I don't see any magic smoke. Alright. Oh, I know what it might be. Let me unplug. Okay, I'm unplugging the USB and plugging it back in. And then if I let it sit for a moment, it may decide to quit on me. We'll let it sit for another couple of seconds here. And actually, yeah, I may have, yeah, it's dead again. And I know what's going on. Alright, so this is not going to be true of all power banks, but I just want you to notice when I unplug this, plug it back in, you will see a little blue light show up. That indicates that it's powering something. And then if I let it sit, what's happening is it's trying to see if anything is drawing power. If there's nothing drawing power, it shuts itself off. So that's what happened. Now I get no sound at all. But we have demonstrated that you can use USB to power these things, these two particular projects, and that is definitely a better start than where I was. Yeah, this is a result. This needs to draw more power in order to get the power bank on, or I need to use a different power bank. Or now that I've demonstrated that it's not overheating my power bank and it's not shorting out, I could plug this into a different source that doesn't shut itself off. So that's two of them that we got up and running because we connected them into these little breakout boards. I can trim these wires off and be better so that they don't accidentally short against something like the screwdriver here. You just want to keep your leads short where you can, but that's a result. That's a simple hack, and I'm quite happy with it. We'll have to figure out what the next hack is, and we'll do that hack in the next hack video. That's it for now. Thank you so much for watching.